Now let's look at an example of a binomial distribution with two Bernoulli trials in it. So in this case, if you remember from binomial formulas, n must be 2. Then k will run from 0, 1, and 2, right? And we said the value should be 1, 2, and 1. How can we see that? It's very easy. So let's say we have two. Let's say we have two binomial trials. So we have 2 coins, and we toss them at the same time. Oh, I got kind of lucky here. Look, they're both tails, so there's no heads here, and that corresponds to one of the possibilities, right, where we have 2 coin tosses, and then they rendered no heads, only tails, 2 tails, right? 2 tails means 0 heads. 0 heads, so, we're counting at 1. So we found one combination when there's no heads. Okay, let's look at another possibility where maybe the first coin toss was tails, but the second one was heads. And we can immediately see that there's another combination where the first coin toss gave us the heads and the second tail. So you see, there are 2 combinations where we observe 1 heads, right? It's tails heads or heads tails. Finally, we have only 1 combination where we observe 2 heads. It's going to be I'll find a better looking coin. It's going to be 2 heads, right? So we counted all possible combinations: 1, 2, 3, and 4. There's exactly 4 possible combinations of 2 coin tosses, right? Tails, tails, no 0 heads, right? Then tails, heads, and heads, tails, meaning 1 heads, and then heads, heads, exactly 1 combination of 2 heads. So we got what? 1, 2, and 1, and they should add up to not 8. They should add up to 4. Let's see how. Right? They should add up to 4, which is equal to power 2. Right? 2 power 2. So we have 2 coin tosses. 2 coin tosses. N is equal to 2, and each Bernoulli trial obviously has has 2 possible outcomes. So we have 2 power 2.